All right, so I want to welcome you to the latter part of our forecasting, and that is on regression forecasting. So by the end of this, you should be able to explain what regression forecasting is. Take one example in Excel and apply it and interpret it. Basically, it's going to be a very brief work. So you can forecast time series of interest. You can take something like GDP. You can take interest rate. You can take exchange rate. You can take any time series of interest called Y, assuming that that Y is linearly related with another time series, say X. So Y here can be sales, and X here can be time. In other words, sales depend on time. Also, sales might depend on seasons. But not only that, you can forecast sales using adverts. So the likelihood is that when you do more adverts, in which case advert is a predictor. Advert is an independent variable. And you can use that to forecast sales. That higher advertisement could lead to higher sales. That is why a lot of companies do adverts. Another example is electricity demand. You can forecast daily electricity demand using the temperature. For example, if the temperature is so high, if it is getting hotter and hotter, people are using their cars, they burn electricity quickly. They burn, electric stove, television. They use their cars more. They use their house electrical appliances more. So the demand for electricity could go up. So every day of the week, you could forecast for electricity demand based on the temperature in the country. What is the current temperature right now, where you are? Who can tell me the temperature now? For example, the temperature with where I am is 29 degrees Celsius. What is your temperature?
28 degrees Celsius.
20 what?
28 degrees Celsius.
28. So your temperature can affect. Another example is consumption. And I'll be using this consumption a lot, so please pay attention. Consumption depends on income. What is the name that we give to the beta one? This beta one, who can tell me the name for that? The beta one. That is the marginal effect of income on consumption. Yes, we know consumption depends on income, but by how much? Beta one tells you by how much income affects consumption. By how much the regressor affects the regressant. The consumption here becomes a dependent variable, also called the forecast variable or the regressand. And then that of the income is the independent variable, also called the regressor or the predictor variable. So the whole idea is that you are using this predictor income to forecast this consumption pattern. Then there is a final epsilon at the end. What is the name of this epsilon? You can tell me. This epsilon, what's the name?
The error term.
The error term. What does it do?
So the error term takes care of calculation errors, computing mistakes here and there.
Okay. The error term takes care of all other factors aside the income that could affect consumption, but you never included them. So apart from omitted variable bias, which is what you are talking about, apart from misspecification errors, it can even be other variables that are not included in this model. For example, you and I know that it's not only consumption, it's not only income that can affect consumption. What are other factors that could affect consumption? But we haven't mentioned them. What do you think? You know, the family size can affect your consumption. You know that.
Yes, sir.
Whether you consume more aquateshi or you consume more travel, you travel a lot, or you consume more dresses or mobile phones, or you buy cars. All of this consumption would depend not only on the income you have, but it can even depend on your family size. It can depend on extra income you may have. It can also depend on your taste and preferences, and so many other things. Now, this error term also calls stochastic noise. It captures all other regresses that could actually affect the consumption or the regressant, but have not been captured. Now, if most of them are omitted, then the impact or the overall percentage influence of the income on the consumption will be smaller. But if they have actually not there, even though you've not included them, but they are not there, if you were to even look for them, you will not get them. Then in that case, income will have a stronger effect on consumption. This is another example, which includes also time. So if you check it, you can see that consumption depends not only on your income, but also on time. So you will notice that sometimes you don't buy things, but at certain times of the year, you will buy a lot, like Christmas, like Easter, like Valentine. You tend to purchase more because time has allowed you to save enough to be able to do that. So we are going to look at this whole consumption regression expenditure using this data set, which is in Hindemann's forecasting book, The Principles and Practice of Forecasting. We are going to use that. This data tracks the quarterly percentage growth. You have the data already. It tracks the quarterly percentage growth rate of key US macroeconomic variables. I'm going to go to the Excel, and then you will appreciate and understand this data set even more. So you can also open yours whilst we discuss this data set, because you're going to use it to do our forecasting. Okay. So this is the data set. Can you confirm if you can see the Excel?
Yes, I can see.
All right. So when you look at this data set, you will notice some few things. Number one, first of all, let me freeze the top part. When you look at this data set, time is on the far left. And the time starts from 1970. And you can see that you have some bit of quarterly information. For example, this first one is January, April, July, and I think October. So you have them, in that situation, the first of each of those months. So that's a kind of quarterly data. You have consumption, which is going to be the main target variable, the forecast variable, the dependent variable, affected by income. But watch it, it's not just income. When you look at the slides, you know that it's consumption expenditure, which is dependent on real personal disposable income. So income is the disposable income. Disposable income is income that has been taxed. what you might call your taxable income or your net income or your take-home pay. That's it. That's the income. And then we also have another variable, which is known as industrial production. Industrial production. In some of the quarters, industrial production is low negative, other quarters is high positive. And then you have another variable, savings rate. So you can see that we have the savings rate, all of it here. This is the savings rate situation for this US economy. Then you have the unemployment rate, okay, which is also there. The unemployment rate is 9%, 5%, 7%, and so forth. Some of them are negative, which is good news. I've included holidays. What do you think holidays will capture? What do you think holidays will capture here? Holidays. It will capture what? Remember, this is time series data. And if you can remember what we've done, time series data is split into three. We have the levels, we have the trend, we have the season. Which one do you think holidays is capturing? Okay, so I see holidays is going to capture seasonality. Seasonality. Okay, so we're going to show the time series of this quarterly percentage changes, okay, of this consumption expenditure. This is personal consumption expenditure and the real disposable income. Now, what's the first thing that we can do? Well, the first thing we can do is to plot the data set. So I'm going to plot the data set, and if you have it, you can follow along with me. How do you plot the data set? Highlight this. Let's exclude holidays, okay? And pick everything. Highlight all of them together with the headings to the end. Go to Insert tab at the top and click on this point called Insert Line. Insert Line. Click on that and choose the last but one. Okay. Choose that particular last but one. You use that one. Okay. And that's what I'm clicking. So once you click that, you're going to get something like this here. Okay. I'll come to the explanation of it, but this thing, if you want it to look good, you can choose any of these. Okay. But one way you can make this thing better is, first of all, click on the far left, you see quick layout. Quick layout. And when you click on quick layout, hover the cursor on each one of them. Okay, hover the cursor. Is this still moving? Yeah, let's try it again. It looks like it's not moving. All right. Let's move it to the right. And then instead of quick layout, just choose add chart element. Add chart element. And then you can add trend line. Okay. We'll come to these things, but I want you to just look at it. You can add a couple of trend lines. But more importantly, we are just going to add the title. Okay. Okay. So just do axis. We're going to remove the title. Just do axis title and choose primary horizontal. Do the same thing and choose primary vertical. And under the primary horizontal, we want to put in the name, the exact name. What name should we give to it? Well, I guess the name we had, if I could remember, is consumption. Okay. And because this is consumption expenditure, I'm just going to keep it like that, as consumption expenditure. So on this axis, on the y-axis, call it consumption. quarterly consumption expenditure, like I've done here. Then on the x-axis, it is the income. It's actually quarterly income. So you click on the axis here, and then you enter quarterly income. Now these things, this time series is looking manya. It's not looking beautiful. So first of all, remove the title. I've just done that. Stretch the thing to the right, and then we are going to remove some of the elements so that it looks much beautiful. At the top, whilst the whole chart is clicked, at the top, click select data. And when you click select data, you will deactivate some of them. So let's say that if I look at the values, income is big. Look at the, let me see income. Savings. Savings looks bigger. Okay. So we can remove savings. We can hold savings for now. We can hold savings. And then we can click OK. So uncheck savings and click OK. So the thing now looks a little bit okay. Okay, it's reflecting that of the other variables. There's something else that we can possibly look at. Go back to the select data, and I think the data are fine because the data are on the other side. I don't know why the data are not showing, but they are all fine. Let's look for another value that is having bigger numbers. It looks like savings is having some couple of bigger numbers. Oh, okay, I've removed savings. Let's look through and see which other one is potentially having a couple of bigger numbers so that we can just hold on. Okay, let's just omit production. Let's just omit production so that the thing will look a bit more beautiful. So it gives you, now the date is even coming. It gives you a sense of how the data now looks like in a time series format. This is what we call STL decomposition. Okay, STL decomposition. So that's it. You have, this is just to plot the data for you to see how the data looks, the quarterly data, how it looks. The next thing to do is, and by the way, I'm taking you back to the slides so that you can appreciate what we just did. So what we just did is something like this. Okay, and then we have decided to just take, in fact, we can do only consumption and income, actually. Let's go to the Excel. Just do consumption and income because I've put all of them together. To do consumption and income, click on the whole thing again, select data at the top, and just remove the unemployment. Okay, uncheck the unemployment and click OK. So now you can see here that we have a structure of just the consumption and income, how both are displayed. You can see that the income is, every quarter the income is moving faster, it's changing faster, big jumps in the income, either big fall or big rise. Okay, but the consumption is just hovering around a specific value, say 1. The next thing is to generate a regression between the two, simple regression. And with that, we are going to take the data set on the next sheet, OLS fitted line. So come here. This is the next data. At the top here is consumption and income. Please note that consumption is the dependent variable. Okay, consumption is a dependent variable, but I've brought that one to the right. Okay, instead of it being on the left, because of the plotting purpose, just for the purpose of the plotting. So consumption is on the right, column B, whereas income, which is rather the predictor, is on the first column. Okay, now let's plot that. Once again, you click income, drag it to consumption, hold the Control and Shift key down, and then you press the arrow key on your keyboard just once. It will highlight everything. Now you go and click at the top, insert, and choose line. And once again, select, okay, sorry, no, you don't choose line. We are going to scatter plot the data. So you're going to choose this section here called scatter plot and choose the first one here, scatter plot. I just did that. Let's make it bigger. I just did that too. Now you can change the color. Click on this section here and choose any of the colors that you want to choose for it. Okay, I want to choose something like this. Now remove the title, consumption, and you can insert X and Y axis for it. Once again, you can go to this section, quick layout, and then select a suitable one that includes, you see, it is showing the axis. A suitable one that includes the fitted line. I like this one, the last but one on the right. This one is layout 9, depending on which Excel format. Choose that one. Done. And now remove the title at the top here again. And then this legend, you can remove them. Okay. You can remove them or you can keep them. Either way. You can also label the axis. I don't want to go into all of those details. And then that's it. I'm interested in this regression equation, which you have here. I'm moving it to this side. Okay. And I'm giving it a higher size, font size. Okay. This is it. It is showing you the relationship between the Y and the X. And remember, the Y is consumption. So I can change this one and make it C for consumption. Or you can even write the full name, consumption. And then the X is actually income. So you can change this one and call it income. And as for and you can bolden all of it. But you can use a different color here to give it a very nice bold. But let me use red. So what you see here, you will notice that there is a relationship between consumption and income, and the relationship is positive. How do you know that? Look at the regression line. The regression line or the trend line is telling you the line of the best fit. Okay? This is the estimated consumption line. And what you had was the actual consumption. The column B was actual consumption. And what you have estimated is this one. And it is showing the relationship between consumption and income. The fact that it's upward sloping from down to top is indicative that it is a positive slope line. We'll come back to the other elements of this, the R square and everything else related to them. But this is an easy way to see the relationship between consumption and income before you do prediction, before you do forecasting. Okay, now we can go ahead and let me show you again how this thing looks like in your slides so that you can even appreciate it more. So when you go to the slides, you have the same regression line, and then you have the equation of the line. Note that if you were using R or Python, there's a function in it called time series linear model. That's what you would have used for this purpose. The one that I just did, that is this, which is also in your slide. You can see that it's slightly different from the one I did because of the coloring. But apart from that, everything is perfect as it's supposed to be. So there's a scatter plot of the linear equation between consumption and income. Now, let's generate this result, because since it's a simple linear regression, we can also generate the result, the actual result. Let's go to a data set. You click the next sheet, which is called result. Okay. But that sheet is not there. There's nothing there. So I'm going to rather go to the original sheet called US change. And we are going to just plot the relationship between consumption and income. How do you do that? At the top, click on Data tab. On the far right, choose Data Analysis. And then a pop-up will come. This is the Data Analysis Parameter dialog box. Go through the list alphabetically and choose Regression and double-click. There you go. And now, the first is the input Y range. So you input your dependent variable, your Y, which in our case is consumption. Click on consumption, drag it to the end, and then collect all the information there. When you go beyond the line, come back. And then go to the next one. Click the input X range. That one too is for the consumption. So go to, that one is income. Go to income, click on income, drag it all the way to the bottom. When you exceed, come back. And then take labels in first row. Labels in first row. And also take, instead of output range, take new worksheet. And let's rename it and call it simple regression or simple reg. Okay. It's going to create a new sheet for that paper. We also want to see something about the residuals. I'll talk about the residuals. Click on this residuals. I will actually be teaching you guys, what do you call it? Research methods, and I'll talk a lot about these ones as well. Quantitative research methods. Okay, so the result is going to create a new sheet called simple reg. Okay, I'm going to click OK, and then you see the results. Watch it. A new sheet just got created. Okay, here, known as simple reg. I'm going to delete this one, which had nothing there. So we're going to deal with this simple reg. What is it? It is a result of our regression. But what is it? Well, this is what it is. It gives you information about a coefficient, which is the most important one here. Okay, you get information about a coefficient, and then the relationship between consumption and income, you'll also see it. If you can remember, we had 0.28. That's the same value you are seeing here. And the intercept was 0.5451. That is also the same value that you are seeing here for the intercept. Okay. Now, this lower and upper confidence interval have been duplicated. So you can click on these columns and delete them. Right click to delete so that they don't repeat themselves. You have p-values here. We'll talk about the p-values, as time goes on. Okay. And these p-values tell you something about the regression. You have the significance F. That is also something that you need to know. You have the R squared. That is also something that you need to know. These are the key things that you need to know regarding the regression result that you are supposed to have. Okay. So first thing I want to find out from you is looking at this. Okay, let me take you back to the slides. Because everything I've just highlighted here, that's the same thing you have in the slide. So this is the slides. Okay. Looking at this 0.28 for income, it is a coefficient of income. What does that mean? What does that mean? The coefficient of income. Remember, we are looking at the relationship between consumption and income. Now, the relationship is positive. We know that. More income, more consumption. We know that. And it is still positive here. But what does this mean? This means that if you should increase income by just 1 unit, consumption will increase by 0.28 units. That's what it means. In other words, if income were to rise by 100%, consumption will go up by 28%. That's what it means. Okay. So it is an interesting result, okay, and it helps you to know that for this particular, sample, that's exactly what you are going to get for that. Okay. Now, the interpretation I just gave you is what you have here. Okay. The same thing. A unit increase in income, okay, results on average in 0.29 increase in consumption. Now, I just want you to note that every time you're interpreting this, bring the word on average. On average. On average, okay, or holding all the other factors constant. In this case, there are no other factors. The only factor is income. Okay. That is why, it wasn't explicit here. Another way of interpreting the results is this. You can say that a value of 1 unit, and this is very important because this is a forecast. So a value of 1 for income. In other words, if you have 1 unit of income, if income rises, if disposable income rises by just 1 unit, it will result in a forecast value. Listen to the word, instead of it will increase the consumption by 20.28 units, you can say that it will rather lead to a forecast value of, then you multiply that 0.28, you put it into the equation. Okay, watch it. Because I'll ask you this in an exam. You put this into the equation. What is the equation? Let's go back here and then you see the equation. This is the equation. So if I should increase consumption by 1 unit, replace here by 1 unit. And when you replace here by 1 unit, you're going to multiply 0.2806 by that 1. And then you will add the 0.5451. So whatever is obtained is going to give you the actual forecast value that will result should you increase consumption income. Should you increase income by 1 unit? Okay, so a way to, and I've done the addition so you can see the result for this. So if I add a 0.55, it was actually 5451, but I've rounded it to 2 decimals. And then 0.28, it was actually 0.2806, but I've rounded it to 2 decimals. So if you should do that, okay, you're going to get 0.83. 0.83. Remember, when you were looking at the actual value, what you said is that if income rises by 1 unit, consumption will rise by what? By 0.2 units, 0.28 units. But now, we are not talking about consumption, we are talking about forecast value of consumption. You know, so if income should rise by 1 unit, consumption is forecasted to be 0.83 units. You add the intercept, which is 0.55, to the slope value, or the product of the slope value and the actual rise, and that will give you the exact results that you have. It's very, very simple when you are introduced, and you should learn how to interpret these curves. Now, let's go to multiple regression. Oh, by the way, let me just show you something very interesting in the simple regression case, in the Excel result. In the simple regression, I also deliberately generated the residuals. Remember, the residuals is just the difference between the actual consumption and the predicted consumption. As an example, look here. This is the actual consumption. Where is that? At the top, this column here is the actual consumption. Let's take the first one so that you can appreciate these things. The first one is 0.6159, 0.6, let's just say 0.62, 0.60. That's the actual consumption you had from the data. Then you estimated this model, and then you had what? The predicted value to be 0.8179. Which one is bigger? Is it the actual or the predicted? Which one is bigger? The actual or the predicted? It's my class rep here. All right, good. So it is the predicted. Predicted is bigger. And so when you find the difference between the predicted and that of the actual, you get a negative 0.20, okay, negative 0.202. And that becomes the residual. That is the error that you would have ordinarily wanted to cut it down. If you take the mean of all of these errors, it should be equal to 0 on average, okay? I just took the mean. On the bottom of my screen here, you see that the mean, the average here is almost 0, because you have an exponent of e minus 16. So it just shows that the expected value of the error term is truly 0. So that is it. That is how you analyze this very section. Let's go to the multiple regression now. So the first one was just consumption. What about if you add other variables to it? If you add other variables, consumption is now being influenced by not only income, but production, savings, and unemployment. Each of the beta coefficients that you see measure the marginal effect of that particular independent variable, holding the other factors constant. And therefore, the beta value will tell you the importance each of these independent variables or each of these predictors have on consumption pattern. When you plot each one of them, just as I did the previous one, you will get something like this. And I've done the plot for these three variables that have been added to the original one, which was income. Now, when you look at this, we want to know the relationship between each of these variables. I took them one by one. So production will look like this, savings will look like that, and then, of course, the unemployment level will look like the green one that you see here. We can run the multiple regression as well. Okay, this is a result that you see. The same thing you did for the simple regression is the same thing you're going to do for the multiple regression. Let me quickly do that. So once again, you're going to do the multiple regression here. So go to the actual data set. This is a data set. Okay, and click on data tab at the top. Choose data analysis on the far right. Select regression. The previous one you did, the dependent variable is consumption. It's still there. It hasn't changed. Keep it that. But this time, the independent variables have become many. So delete what is here and select all the independent variables. I'm going to even include holidays. Okay. Even though the one you have is not really, no, let me not include holidays for now. We'll look at that separately. So I'm going to include, for the independent variables, I'll include income, production, savings, and then unemployment. Hold the control key and the shift key down and click arrow down. And it has selected all of them, okay, into the input X range. Now, I want a new sheet to have the results. I don't want the residuals again, and I want to call it multiple regression instead of simple regression. So I put a dot so that doesn't conflict with the other one. Once you click OK, a new Excel sheet called let me just call it multiple regression. Okay, and click OK. It normally comes first and is the one that has come down here, okay, which is the first one that you see. What does this mean? Well, zoom in a little bit and you will see that now that you have included the other variables, the R square has gone up. What is this R square? The R square measures the percentage variability in the dependent variable, which in this case is consumption. The percentage variability in the dependent variable caused by all the independent variables, okay, or explained by the entire regression line. In other words, if you combine all of these independent variables together, when you bring their powers together in percentage terms, they are all together, they are influencing the dependent variable consumption by 75%. That's what it means. Okay? That the R square is a key determinant of the fitness or the reliability of the regression model. Now, sometimes you use the adjusted R square. The difference between the adjusted and the R square is that the adjusted penalizes the inclusion of irrelevant variables. So if some irrelevant variables are not supposed to be included, but you have included them, the adjusted will bring the value of the R square down. If it brings it down by big, it means that a lot of irrelevant factors are included. And so you got to check your variable. In this case, the differences are not that big. One is 74%, 75%. The other is also, if you convert to 2 decimal places, both of them are 75%. So what does that mean actually? Suppose the R square is 75% exactly, and adjusted is also 75% exactly. What does that mean? It means that there are no irrelevant variables included in the model. This is my exam question. Okay? That's why you got to take note of some of these things. So that is how you interpret the R square and adjusted R square. Now let's come back to the intersect, I mean the independent variables. You remember that before income alone was influencing consumption by 0.28. But when I brought the others, look at income now. When I included the others, you will notice that income is now influencing consumption by 0.71. It's moved away from 0.28 to 0.71. What does that mean? In other words, the presence of other people around you in life can make you be better. For example, a husband may be nothing before getting married, but after marrying that woman, the husband's everything he is doing seems to be doing well. His life is getting better. His situation has improved in life, which means that the presence of other people around you can improve you. But it can also be the other way around, that the person was rather doing well, and after the marriage, the person is doing worse. The same thing with a woman. A woman may be nothing, and yet after the marriage, all her life has ballooned to a positive angle. That is an example of what you see happening to income right here. Okay. Now, if you want to know whether all of them, you remember the R squared talks about all of them combined, how they influence the dependent variable. If you want to know whether all of them combined, whether they are significantly influencing the dependent variable, check the F statistic for the ANOVA. The F statistic for the ANOVA. By the way, this value, E minus 54, means that there are 54 zeros before the 262. In other words, you have 0.00054 times before 262. It simply means that this value here is 0. Anytime you have something like that, that is what it means, that the value is 0. Let me delete the confidence interval because it's been repeated, just as we did for the simple regression. And now let's go and look at the importance of each one of these independent variables. Income is influencing consumption. Production is influencing consumption. If savings is influencing consumption. Unemployment is influencing consumption. By how much? By the coefficients that you see. So as an example, you can see the unemployment rate is negative. What does that mean? It means that when there is a higher increase in unemployment, consumption falls. That's what it means. And this is true. When unemployment is going so high, consumption that would have normally gone up will go down because people don't have enough, disposable income to be able to make some, magic activities. So unemployment will be negatively correlated with consumption. The question is that significant? If you want to check whether any of these variables are significant in influencing the dependent variable, always check this section known as the p-value, for each independent variable. Whenever the p-value is less than 5%, is good news. The same thing for this one here, the F statistic. The significance F here means the p-value for the F statistic. Anytime the p-value is less than 5%, is good news. Now, if you check all of these, okay, the first two in particular, you'll notice that they are less than 5% because there are so many zeros. So they are basically 0. If we check this third one here, it is 0.07 or approximately 0.08. So that is 8%. But for it to be significant, it has to be less than 5%. So production will not be significant. So when you check production will not be significant. When you check savings, it's 0, so it will be significant. When you check unemployment, it is not significant because instead of it being 5%, when you round it, when you multiply this by 100, it's rather 5.3%, or basically 5.4%. So once again, I'll put a red there, and you will notice that unemployment is not significant enough. It's not significant at 5%, but if suppose you put a significance level instead of 5% significance, okay, you rather decided that you will look at 10% significance. Then you can say that in that case, unemployment is significant at 10%, but it's not significant at 5%, and it's also not significant at 1%. These are the main significant values we always will ever deal with. So that is how you do multiple regression. Multiple regression. You got to master this and you got to learn it well and you got to apply it into this. Now, the same way, when it comes to multiple regression, let me go to the slides. Okay. Most of the things in the slides, I've mentioned them. So let's say that this time you want to predict the consumption. Okay. If income is 2,000, production is 10,000, and saving is 20,000. What will you do? And unemployment is 17%. How would you do that prediction? Ladies and gentlemen, it's very simple. What you have to do is to take these values. So watch it. Okay, I'm just going to manually do this for you so that you know how it works. So you are looking for the value of consumption. And consumption will be equal to this first value. It will be 0.27. Then plus income. So you do plus 0.71 income. Okay, let me just write Y. Then you do plus 0.05, and I'm just checking these. Production. Then you do minus 0.05. What I'm doing is called estimated equation. Savings. That's for this one. Then you do minus 0.2, and then unemployment. You don't need to bring the error term because by the time you estimate the model, the error term is gone. Okay. So now, this is the equation. And you have been told that income is 2,000. So what you do now is that you come to this section here and replace your income here with what? 2,000. And then you are told that production, somebody should be substituting them for me. And let me see. Production is 10,000. So you come here, you substitute the P with 10,000. And then you are told that savings is 20,000. So you come here, replace the S with 20,000. And then finally, unemployment is 17%. So you come here, replace unemployment with 0.17. Now, you should add them all together or simplify all of them together. And that will give you the value for C, which is the consumption. That value will be the predicted consumption value. Okay? That will be the predicted value for consumption, knowing the values of these other independent variables. That's how you do prediction. So prediction for regression is very simple, you know. And the question is that your question is this powerful? Is this prediction that you have made? Is it? I don't know the value, but when you substitute them, you will know the value yourself. Okay? So you should substitute them and then calculate the value yourself. Okay? If you have been able to do it, you can just let me know. Anybody here who has been able to do what I just did, just let me know. Okay? That is it. That is how you determine the predictive value. Now, if you want to know whether the value is powerful, whether it's reliable, you check the R square. I've told you before. When you check the R square, and generally the R square is 50% or more, it means that, in fact, it can even be less than that, but I'm giving you my rule. If it is 50% or more, it means that the regression model is reliable, is suitable, is well fit. And so it means that your prediction you just did is believable. Is believable because the R square is very strong. R square is strong, then the significance F is also 0. That means that you have some good news. And when most of the P values here for the independent variables, each one of them is less than 5%, that is also indicative of the fact that you are doing well with your model. And therefore, your prediction that you just did is super reliable, super reliable. That is how you undertake the principle of forecasting or prediction when it comes to that. Now, which of these independent variables is powerful enough to predict consumption? Well, one thing you have to do is to be able to generate a correlation matrix. The correlation matrix can help you to have a fair idea of which one is important and predictable. Now, how do you do the correlation matrix? Again, that's simple. Let's go and do that in Excel. So I'll go to my data here. I've created a section here called correlation matrix. Okay. I want to just delete even this and create a new one because we are going to do it together. To do the correlation matrix, click on Data tab again. On the far right, click on Data Analysis. Then you select Correlation. Go through the list. You see Correlation. And once you select Correlation, this is what you do. Click on the input range. Now, where do you get the input range? The input range are in this sheet. So I'm coming here. You're going to click on every one of them, each one of these values. Remember, the input range should also include the dependent variable. So I'm highlighting all of them, excluding the time. Okay. And then take the labels in first row. And where do you want the results to be? Well, here we want the results to just remain here. I'll just click on cell A1 and click OK. It says error. Okay. All right. Normally, ideally, I'm just doing it one more time. Other than that, you just have to copy and bring them. You just have to copy and bring them into the, what is the correlation? Yeah. All right. So one thing we can do rather is, because it's on a new sheet, so let's just bring the entire data. In fact, you know what? Let's just do it rather here. Let's do it rather here. Correlation. Just that I didn't want it to be. So whilst we are in this section, let's just do it here. So I'm highlighting everything into the input text range, labels in first row, and then here I want the results to be rather down here, below the graph. Okay. And because I want the result to be below the graph, I'll just click this section here. And now you have your results here. So this is called a correlation matrix. If you want it to be in 2 decimal place, go to Home and select this point, General here, General. Select the General and choose Numbers. Everything will be in 2 decimal places. So what does this tell you? This tells you the most important column is this. Okay, that column shows the relationship between consumption and every other variable. For example, if we take this value called 0.4, 0.4 shows the relationship between income and consumption. It's positive. Okay. When you take production, it's positive. When you take savings, it's negative. When you take unemployment, it's positive. Okay. And you want the correlation to be stronger, bigger. Okay. Whether it's negative or it's positive, it's supposed to be stronger. And sometimes it's good, sometimes it's not the best. It tells you clearly from here that some of them have got a bigger value, some of them have got a lower value. But the best one to use is the one that we did already, the multiple regression. So the multiple regression here, when we take the coefficient, it helps you rather to know which variable is important in predicting the consumption level. And when you check it, you can see that income is 0.71. All the others are quite low. Okay. And so income is a very, very important variable in affecting this element of consumption. That is how this section is generated. But there's a lot of questions you will learn from correlation. And in your thesis, some of which I will supervise you, other lecturers will supervise you, you will use this approach to undertake this consumption. I'm looking for very, very ready people. I have topics for you. that I'll give you and supervise you if you are hungry to really, really want to make some good research. Okay, one interesting thing you should know about this correlation is that you can identify variables that are multicollinear. The 1, 1, 1 in this diagonals means the perfect correlation. So the first one is a correlation between consumption and consumption. The second one is a correlation between income and income. The third one is a correlation between production and production. So these are perfect. They are not just high, they are perfect. Then we have high. High ones are those whose values are bigger, like negative 0.78 here, like 0.71 there, and like 0.55 there. They are high. They are high. Now, what you don't want is for an independent variable. Forget about this column, consumption column. So suppose we take away this consumption column. We don't want a situation where any of this independent variable, any of the numbers here, we don't want a situation where any of them will have a high correlation value, a high correlation coefficient. No, we don't want that. Why? Because if that happens, the two variables are said to be multicollinear. Multicollinear. We'll talk more about this, in subsequent lectures. So multicollinear, write it down. Multicollinearity occurs when two independent variables are so highly correlated that it becomes difficult to disentangle the partial effect of one from the other on the dependent variable. In other words, multicollinearity happens when two predictors are close to each other in their values. They are so close. They are so close that you don't even know. I mean, separating them will have an effect on the dependent variable. They are too close. So in other words, one is redundant. And so one has to be removed because of the superfluidity. That is in superfluousness that is inside the data caused by one. For regression to work, like we have gone through all this, for regression to work, certain things must be in place. For the University of Ghana to be running, lecturers must be in place, students might be in place, the blackboard must be in place, the markers must be in place. So once I say the UG is running, then you know that all these are in place. Once regression is happening, then all the following things I'm going to mention must be in place. There must be zero mean of the residuals, the errors. They must be heteroscedastic. Oh, watch this. The errors should be homoscedastic. I don't know why I wrote heteroscedastic, so please change this one. It's supposed to be homoscedastic. So the errors must be homoscedastic. Homoscedastic means that there's constant variance. Heteroscedastic rather means not constant variance. Okay. So they must be homoscedastic. And then they must also not be autocorrelated, the errors. The same way the predictors must not be multicollinear, the errors must not be autocorrelated. And the predictors must also not show any endogeneity. You will learn more about endogeneity and how to address it later. And these are called assumptions. Certain things that must be in place for certain things to work. Assumptions. And that is how you do. My goal is basically to just show you how to do prediction. You can tell which predictors to select. And there are several ways you can tell which predictors to select. Remember, we are talking about forecasting here. So you've done your forecasting. Which predictors are you going to select? I gave you one approach of using the correlation. I gave you one approach of using the regression scores. Another approach is to plot the forecast value. That's what people do, but that's wrong. Okay, one wrong approach is that they will focus the consumption against the income. And then they will drop any of the independent variable if that independent variable doesn't have, it's not noticeable. It's not showing any noticeable link, positive or negative link. Then they will drop it. It's wrong. Another people will drop the predictors, the independent variables whose p-values are bigger. Just like we saw that some of them, the p-values are big, like one of them was 5.3% or 8%. So it is insignificant. So what some people do is that, so since you are insignificant, then we don't need you. It's also wrong. Because statistical significance doesn't always indicate predictiveness. It doesn't always indicate that, oh, because you are statistically significant, then you've got a higher predictive power. No, 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 no. No, no. For example, being a man doesn't show masculinity. Being a man doesn't mean that you can beat a woman. It's not true. Some women can jofo your man for you, and then you fall down many times. So you can't use this as a way. What you got to do is to use proper measures of predictive accuracy. What are they? Adjusted R-square. Adjusted R-square. The Schwartz-Bayesian information criterion. The cross-validation approach. The Akaike information criterion. The corrected Akaike information criterion. The one that I love the most, which is used, are the last three. The CV, the AIC, and the AICC. You will learn these properly, in further analysis of prediction. So prediction is a very, very important thing, and you can do that. Now, the last thing we're going to do now has to do with the data set, the time series data, when you have included trend and dummies. Remember, I told you, I did even one where you have included the trend. But you can include trend, you can include season, you can include dummies. So here I have a model here, a very simple model, where Y is a dependent variable, and it is dependent on X1. Now let me use a different color. Y is a dependent variable. The Y dependent variable relies on X1, relies on time, relies on dummy. The dummy variable is the one that can be 0 or 1. A man, a woman, that's a dummy. True or false is a dummy. Young and old is a dummy. Okay. Primary school, secondary school, tertiary school is a dummy. Okay. So these are the dummies. Now you can include all of them. So this is a typical example of an equation that includes what? A time trend and a dummy called holiday. What do you see here? You will see that the holiday is having a negative relationship with consumption. Time is having a negative relationship with consumption. Income is having a positive relationship with consumption. And then on and on and on. Once there is this situation, your predictiveness of the consumption becomes slightly different. You will learn more of this when it comes to ARIMA model. Okay, so I'll leave that when I come to ARIMA. So that's it. What is the main takeaway point here? Well, the first one is simple time series models are used for short and medium term forecast. Simple time series, okay? Like just modeling consumption and time. But regression is good, okay, when you are dealing with long-term forecasting. So all the ones we have done, the naive forecasting, the simple moving average, the weighted moving average, the halt and the halt winter, double and triple exponential smoothing. All of these, they are used for short and medium term and short term. But when it comes to the regression we've just done, it is usually used for that of long-term series. That's it. Next time, Dr. Ferguson is going to take you through the first step of the ARIMA model. Ladies and gentlemen, that brings us to the end of the entire caboodle. If you have a question, please feel free to ask.